This is day 2 of the border problem. The students and teacher have together formed a written description of Joe's method for finding the number of unit squares on the border of a 10 by 10 grid. The description is shown on this overhead. We join the lesson as the teacher asks the students whether there is a way of writing the method in a shorter form.
What they would do then is they would say, well, is there a way to shorten this? So how could we shorten this without doing all the writing and still communicate Joe's method so that we could understand it? Does anybody have any ideas about how we could do that? You do, Krista? How?
Like with using algebra, like they make the 15 and the 15 like x's and the 13 and the 13 y's, and so then you could say like x plus x, and then label the square x plus x, and then put it all in letters like as algebra.
I really like Krista's idea of taking some kind of a symbol, or and she's using a letter. Does anybody know what letters are called in algebra? What they're called?
Like what they're meant for?
Well, actually, they have a name. The name doesn't really say everything about what they do.
Like a
They're called variables.
I knew that.
They're called variables. You've heard that word before? Okay. So let's take Krista's idea and work with it. Let's pick a symbol and let's say for, you want to use X, Leo? You guys like X?
Yeah.
All right. We could L for, you could choose L for Leo, A for Anna, K for Krista. So now what are we going to do?
H for Miss Humphrey.
H for Miss Humphreys. How about well, I have an idea. All right, I have an idea. How about if everybody pick their own variable? So let's all pick your own variable. I don't care what it is in the book, but we have to tell what it means. Okay, I'm waiting for quiet. And okay, so what we're going to do is we're going to say let, and you get to pick your own variable, and I'll pick, I don't want to pick one, so let something equal, and this is the important part. Okay, what I'd like to be able to do is talk without being interrupted. Up here, this first sentence is the most important thing, because it says what you need to know, what Joe needs to know to figure out the number of squares. The only thing Joe needs to know is how many unit squares are on one side. That's all he needs to know. So what we want to do is we want to let our symbol equal the number of unit squares on one side. And I guess I'm just going to use X because it seems strange to leave it blank. But you all can choose whatever one you want. But it's really important that you write this part out. Let X equal the number of unit squares on one side, and of course you might not have X. Now here's what I'd like you to try to do in your tables. I'd like you to try to translate this into an algebra expression. Like Joe is telling us what to do. Here's a picture of what Joe said to do. Here's some examples of what Joe said. And before we do, let's just look at these for a minute. What's staying the same in this arithmetic? Pam, what's staying the same?
You're always adding. If you're not, you could multiply, but you're always adding.
Okay. Anything else staying the same? And what is changing? Sarah.
Well, the first two numbers are the same numbers, and then the last two numbers are the same.
Okay, so these two are the same, but those are different. So do you think that you could look at this, and look at this, and write an algebraic expression? Or why don't you try at your table?
Okay.
You try your table.
Well, my variable was s, and so it could be s plus s minus 2 plus s minus 2. Though that's kind of complicated. Is there any other way to put it?
What is it?
Mine was s minus 2 plus s minus 2.
No, we have to like. How about we write a
Where on the picture?
on the C13 we make a variable for 13. You know, and then they
Yeah,
yeah, this I'll
Oh.
make an N.
Have to be the same as your variable, right? Okay, Krista's case. And you have to create another letter.
okay, so it's s plus s plus
That's a really important
M
question. Do you
plus
think you need
M.
to create another letter?
Another one.
That's what you were talking about? Okay, may I please have your attention at this table for a minute? Do you want to say the theory? Your theory? About the other letter?
Okay, well, we knew that we had to add like the top and the bottom, or up there would be the green. And we knew that that would be our just say our variable is m. So you have to add m plus n, but we're trying to figure out a way of subtracting 2 without saying subtracting 2 from the sum of m plus n. So we figured that we need another letter for the 2 sides, but we're having a hard time figuring out how to say it.
Why don't you check and see if anybody has any ideas for you?
I don't understand.
Oh, wait a second. Does everybody understand the issue at this table?
No.
Oh, Travis, what's the issue at this table?
It's what I had it. I knew exactly what
You want me
Say it
to
again.
try and
Yeah.
Okay, so we're adding the top and the bottom, but we're trying to figure out how to add the sides, but we know we have to subtract 2. And we don't know, you can't just say the top plus the bottom minus 2, because that would mean you'd be subtracting it from the sum of the top and the bottom. So we're trying to figure out, we know we have to use, we think we have to use another letter, but we're having a hard time figuring that out. What, like, how to say subtracting 2 with the other letters.
So since Pam went to all that trouble of explaining, Mindy or Kayla or Joe, would you choose somebody in the class to help you or give you ideas?
I think maybe you could like do x plus x for the top and the bottom, or whatever letter you're using, and then you could do x minus 2 plus x minus 2. And that would give you the total border.
And then you wouldn't have to do another lecture because
Yeah, and then you could just keep the same letter,
Okay.
and you're still taking away 2.
Why does that work? Why does that make sense? Melissa, why does that make sense?
all those sides are the same length, so you only need one letter and you have to subtract 2.
Okay. That whole thing about why you might need another letter. Kimberly, you were thinking that you needed another letter, right? Why were you thinking that? Because that's a really important thing. When do you need another letter and when don't you? Why did you think you did?
Because we have 4 letters, and I was thinking because she read her thing there, and I said it was kind of complicated, so I was thinking we need another letter.
Okay. What do you think now?
We don't need it anymore.
You're sure? You're convinced?
Yeah.
Okay. Travis, were you going to add anything to that? Okay. Yeah, Pam.
The reason I was thinking that we needed another letter is because in the beginning we needed two different numbers. So maybe you needed 2 different letters.
Oh,
It kind of like because we were talking about what's the same and what's different. So in the algebraic formula, the things that are the same and different are not the same and different on the numbers.
right.
So I think that when you asked what was the same and what was different, kind of confused me.
I'm I'm glad it confused you in that way, because it brought out a really important thing that we're going to be grappling with in some other problems. Because sometimes you are going to need a different letter. And sometimes you're not. Why don't you need another letter in this case? I mean, like, if you can do it without another letter, you want to keep it simpler. Why can we? Sarah. Yeah, this Sarah. Sarah Stanley.
Because you can do things to that letter to make it the number that you want without using a different letter for that number.
And in this case, the thing that you're talking about doing is...
I used S as my,
Okay, so let's write down S for... I'll write down S for Sarah.
okay.
Okay.
And so I said, in parentheses, I said S times 2.
Now,
And-
Sarah, I'm going to stop you here because I agree with you that S times 2 is the same as S plus S. But I want to keep it as consistent with the way Joe
Okay.
is seeing it as possible. So I'm just going to say S plus S.
Okay.
Okay?
And then I said, that's in parentheses, and then I, outside of the parentheses, I put plus, then, parentheses, S times 2 minus 4.
Ah.
but it's a different method.
Okay, so maybe that's a different method. Can you think about what Joe would actually do? And actually, that's another method I want to come back to. That's interesting. So Sarah, and actually, I'm going to write this down. Sarah wrote S times 2, Sarah, and then you wrote plus S times 2 minus 4. We're going to have to come back to that. I don't want to lose it, so I'll save this transparency. But what would Joe have done exactly, Travis?
S plus S,
Okay.
and then plus S minus 2,
Okay?
and then plus S minus
Let's see. Who would read their sentence to us? I know the bell's about to ring, but would anybody? Oh, darn. Okay. Think about this tonight. And tomorrow we'll get to work on it some more. Tonight's homework